Okay, hello and welcome to the Knox Makers KM-001 logo badge build kit. In this video we're going to walk through a little bit about how to solder, how to build this kit, how to troubleshoot and debug it, and hopefully you'll have a cool project to show off to your friends when we're done. So to start, just open up the bag and pour the contents onto your work surface, being careful not to let anything drop and fall on the floor. You should have a battery holder or battery clip, a few LEDs, a strip of resistors, and a printed circuit board. When we build these projects, what we typically do is start with the lowest profile components first and then build our way up from there. We tend to build everything on one side first and then work our way to the other side. So in this case, for this board, we'll start with these resistors. So the resistors are contained in a little strip here. Just pull the sticky strip ends off. You don't have to worry too much about something getting bent up a little. It'll be fine. Should be left with a handful of just loose resistors. Now resistors, a couple things about them. First of all, they can be placed in a circuit in either orientation. So you can turn it one way or the other way, it doesn't matter. The other thing is there's some bands on here that describe the value of the resistor in resistance. A wide range of resistances could be used in this kit. You can use whatever came with it. The little LEDs actually don't require a resistor. This particular style of self-blinking LEDs do not, but I included them here in order to protect against any fault conditions. If something's shorted or something like that, it doesn't short the entire circuit out, it just shorts out that one LED. Make it easier to debug later. So these resistors, they typically go into some slot, as you see here, it says R2. There's a little silk screen outline there, and the resistor is going to basically just be placed in here. That'll be true for all of these. In order to do that, grab the body of the resistor between your index finger and thumb. Other hand, just bend the leads over so they're at about a 90-degree angle. And then you just insert them into the holes in the board, like so. Then reach around to the back. So hold the component down on the front with one finger, one hand. Then on the back, just bend the leads out. And that'll hold the component in place nicely when you go to solder it, okay? So to solder it, I'm going to just flip the board over. Now it's going to get pretty hot underneath, so you don't want anything on the work surface underneath here that might be damaged by heat. I've got my solder iron nice and heated up over here. I'm running about 725 degrees Fahrenheit. The particular temperature that you need to use will depend on the solder iron tip, the iron itself, the board, the solder you use. A number of factors affect that. This is what I'm using here. You really just want to adjust the temperature up and down. You want to use the lowest temperature you can get away with, but a high enough temperature that you can get the job done relatively quickly. So I'll start by just tinning. They refer to this as tinning, just putting a little solder on the tip. I can see that the tip is taking solder pretty nicely all around it. Looks pretty good. And this tinning process actually cleans the tip. Inside the solder, there's some solder flux that's in a core inside here. When you melt the solder itself, the flux is released inside. So a lot of that smoke that you see is actually the flux burning off. And that flux removes oxidation that may have built up on that tip. So we do that regularly to keep the tip clean and healthy. Now the key thing you're doing when you try to solder, when you're soldering a component onto a circuit board, is you're trying to heat up both the lead here from the component, the resistor, and the ring on the circuit board. Bring them both up to a very high temperature and feed in solder. The solder will reflow, and if everything is at a high enough temperature, if everything, both the ring and the component lead are above the melting point of the solder, then it will wick up the lead and around the circuit board and give you a nice solder joint. So that's what we're trying to do. So I'll place my lead tip. I'm going to wipe it off on my little solder sponge over here. I'm going to place the tip of the solder iron where it's touching both the lead of the component and the ring on the circuit board. Then I'm going to feed a little bit of solder in here and you'll see it flow pretty nicely. Pull it away. I've got a pretty good joint. Has a nice bit of solder on both the lead and the circuit board. Then I'm just going to repeat that on the other side. It doesn't really matter that much how much solder you flow into here. You could flow a little on the light end. You could flow it very heavily where there's a big blob. As long as you get the lead and the PCB both heated up nicely and the solder flows nicely, you're going to have a good enough joint. We're not trying to send a rocket to Mars. We're just building a project, to use around the house here. So that's it. So at this point, I've got a nicely soldered component. I like what the solder joints look like. Components nice and flush on the board, I'm pretty happy. When you look around online, you'll see things like you should look for Hershey's Kiss view on where these through-hole components or meet the PCB if you have a proper solder joint. And if you have everything sized just right, that can happen. With this board, what will often happen with these is we may have holes, like in this case with this component, the through hole on the PCB is relatively large compared to the wire that's feeding through, so you don't tend to get that little Hershey's Kiss type of a thing. You don't get as much of that, but you still have a good solder joint. So after that, we just clip the leads off flush with the circuit board. Again, it doesn't really matter, nothing real critical here, just cut them off, and you've got your first component soldered. So all these resistor values were the same, all these resistors are of the same value. So we'll just go in and place those throughout the board. I usually find it's easiest or most efficient if I just go ahead and put all of these resistors in one go. Hold each one down to keep it flush. Bend the leads around the back to hold it against the board while I solder. You may have a couple of extra resistors, you may or may not. Sometimes there's a few extra. When we're putting these kits together, we'll put them in there for the unusual case, maybe someone loses one. So if you have a couple extras, don't worry about it. You can just put them aside. They won't be used. Okay. There are 6 of these resistors on this board. I'll have all 6 of them in. Check that they're all nice and flush with the board how I like them. Flip the board over. Going to again wipe my solder iron tip off. I may hit it with a little solder again, just make sure it's getting some nice flux cleaning action on there. Then I'm going to go around and I'm just going to solder all these components in place. So again, you don't have to get too worried about the details. Don't have to overthink this. You can do that if you start making automotive grade products that have to live in an engine bay. That's not what we're doing here. As you learn to solder more and more and become more proficient, you'll learn to be able to do these solder joints quite quickly. These resistors are not particularly fragile. You could leave the soldering on there for quite some time. It isn't going to hurt anything. Some components, that's not as true. There could be plastics that will melt or something that could be damaged, but these are very forgiving. So you generally want to get in there, get your job done, and get out. Hopefully within just a few seconds. You can always leave your tip on there for an extra second or two if you're not sure if the solder's really flowed nicely. Sometimes it's easy to see, sometimes it's not so easy to see. Then when we're done, just walk around the board, clip all the leads flush. Okay, clean these leads out of the way. Now, got this nice board with all 6 resistors in place. Now we'll move on to the diodes, the LEDs. So LEDs do have an orientation. You can notice 2 things about these. One side has a longer lead and one side has a shorter lead. The longer lead is what we call the anode, the shorter lead is the cathode. The anode is the higher voltage side, the cathode is the lower voltage side. There's also a little flat. One side of this LED has a flat edge on it. And that is the, that's the cathode. It looks like what I'm feeling here. So those are the 2 different ways that you can determine the orientation of an LED. The other would be plug it into a circuit board and see which way it lights up. On this board, you'll see, this PCB, you'll see a little A for the anode next to most of these diodes. A couple of them it's covered up because there's other silkscreen there for the logo. You'll also notice the A is next to a circular pad and the other pad is a square pad. So the anode, or the longer lead, must go in the side with the A, or the circular annular ring on the circuit board. And this is important. If these go in backwards, they will not light up. It's easy to fix it now. If you need to flip them, it's much more difficult once you've soldered it in place. So these will be soldered just like the resistors were. Try to hold the LEDs nice and flush against the board so they sit flat and they kind of point straight up, perpendicular to the board. If some LEDs are sort of pointing to the side or pointing diagonally and others are pointing straight up, they will appear a different brightness. So for everything to look nice, try to get them pointed nice and straight up for you. And then remember these two diodes in the middle. This is both D6 and D5. The indication on there is that the circular ring gets the long lead, the square pad gets the short lead. So I'm putting all these diodes through, and then we'll flip this board over and solder them in place. So the last thing I'll do before I solder them all, kind of look at the board, make sure everything looks like it's sitting flush, looks good. I'll flip it down. And let's solder these in place. So I'm using a tin lead solder. Some of you may be using a lead-free solder, some maybe not. I still mostly use tin lead. I find it a little easier to work with though, particularly maybe starting out if you haven't done much soldering, you might find it a little easier to work with. As you do more and more of it, you may find it easy enough to work with any solder type. So I'm shooting this video in the classroom at Knox Makers this morning. It's a beautiful Sunday morning here in Tennessee, and a few other makers in here this morning are working. I can hear a table saw going, maybe the joiner going, or planer, I'm not sure which it was. There's some folks over in 3D printing doing some work. Some folks over in fabric arts. There's always people in the woodworking shop. It's a nice active Sunday morning, so someone may come in and make some noise. If you hear any background noise, it's probably makers making. All right, so I'll now have all of my LEDs soldered in place, all the leads trimmed off. I kind of look at the solder joints, make sure I'm pretty happy with them. I'm not. I forgot to solder this one. I have a little shallow solder joint. But again, this will work just fine. It's not going to cause any problems. Well, we'll see, right, when we light it up. Okay, so these solder joints all look pretty good. I'm happy with them. So last thing we need to do is put the battery clip in place. Okay, so battery clip allows the battery to slide in from one side, like that. I find it a little bit easier if I orient the battery clip this direction. You can see this little plus, if you can see that. On the center side, the interior of the PC board lets me slide the battery in from the bottom. I find that a little easier. You may or may not. And this is going to be a little more, it's going to take more heat to solder this. So it's still easy to solder, but because it's a much larger piece of metal, depending on the size of the tip of the iron you're using and the temperature you're at, it may take quite a bit longer to heat up. So I actually just brought my temperature up to about 750. I'm not using a particularly small tip, probably don't even have to do that, it's just out of habit. Then again, I'll come in here and I'm going to get the solder iron tip nice against the battery clip and against the PCB. And I'm going to feed some solder in here. Take a moment till it reflows. There we go, looks pretty good. You want to make sure this battery clip is sitting nice and flush. One thing you could do if it didn't look like it was flush, you could reflow the solder, push the battery clip down gently with something that won't melt. Oops, and then wait for the solder to cool before you pick it up. My solder wasn't quite cooled and hardened yet. Okay. Then between a lot of these joints, I'm just reaching over and wiping the tip of the solder iron off to keep it nice and clean. It's the best things you can do to keep your solder iron tips healthy, which makes soldering much more pleasant, is to regularly tin the tip of the iron, put a little solder on there before you put it back in the holder. A lot of people, they tend to wipe the solder iron tip clean, then put it in the holder, which then leaves the tip exposed to be oxidized. If you do it this way, put a little solder on it first, then put it in, it'll kind of encase and protect the tip. All right, so the magic moment. Slide the battery in, goes in the plus side. The battery should have a plus indicator as well. You can see that. Goes in this way. And hey, if everything went according to plan, all your LEDs should light up. So if you're done, congratulations. If things don't light up, here's how you troubleshoot it. First thing is, if nothing lights up on the board, probably there's something wrong with the battery or the battery cage. Battery could be in upside down. If you do that, it won't damage anything, but nothing's going to light up. So the battery needs to be inserted fully so that it's making contact with the metal circle inside on the PCB and squeezed into the clip, making good contact there. So you might move that around a little bit, hopefully get good contact there. So that could be the case. Possible there's a dead battery. I don't know, maybe they gave us a battery that's been on the shelf for a long time. So that's certainly possible. If you have access to a voltmeter, at this point, if you check these things out and you think your battery is good, you think everything's soldered in, okay, what's going on? You could use a voltmeter and you can actually probe around on the board. And if you put the negative lead of the voltmeter on either of these points and take the positive lead and start touching it around, say either side of these resistors, one side of that resistor should measure something around 3 volts, about the battery voltage. If you don't see that, probably you got a dead battery. Hopefully not the case, though. I haven't seen that yet. Let's see. So then if some LEDs are lighting up, but not all of them, then there's probably something local to that specific LED. 2 things to check. One is if an LED, say D1, was not blinking, then I would flip the board over. I would check my solder joints at D1, just reflow them again, get them good and hot, and make sure the solder flows nicely. That should be good. Check on both the diode and the resistor. That should fix your problem. If it doesn't, then I'm afraid you likely have the LED in backwards. It's always possible that there's something wrong with the LED, but it's very unlikely. It happens though. You could check it after assembly, maybe use your phone magnification, something like that, phone camera to magnify. You can look in and find the flat edge and make sure it's on the right side, the correct side. If you find it's backward, it's a little tricky to remove it. What you can do is take your solder iron. You could bridge both of these leads at the same time to get them both to reflow, maybe holding the board up and get someone to use some pliers and try to gently pull this out without damaging it, something like that. Pull it out, straighten the leads up, flip it around and put it back in. So a little bit of a hassle, but it can be done. And that should do it. You should have a working kit, should be blinking away, should be ready to show it off to your friends. So, hey, I hope you had a good time. Hope you learned a little bit. And hope you enjoy this and some of our other build kits that we have at Knox Makers. Thanks.